right, thanks so much, Teresa, for introducing us, and welcome to the panel on consumer apps built with ZK, MPC, and FHE. I'm also super excited about this panel here. How I'm thinking of these projects is we have two of them that actually build primitives, so ZK Email and Taseo. They're building sort of libraries and tools. And then we have two of them who built on top of them. So we have ZK P2P that built on ZK Email, and then Cursive, which uses Taseo as well as MPFHE. So this is a really good representation across the stack, and I have lots of questions for you guys. So I want to first start with an intro. Can we get ZK Email, ZK P2P, Taseo, and Cursive in that order? Yeah.
Sweet. Yeah, I'm Aayush. I work a bunch on ZK Email. The idea is you make proofs of emails in your inbox or emails you've sent, and these can get proved on chain. We've thought a lot about what are both the interesting apps you can build and what is the best kind of dev tooling to do that. And on the side, I also like thinking about MPC, FHE, and things like that. So happy to also jump in there.
Cool. I'm Richard. I work on ZK P2P. We build P2P marketplaces that connect Web 2 assets and like digital goods with Web 3, like smart contracts. In particular, we have like a P2P like on-off ramp. So basically, you can send money from Venmo and use that to trade directly for USDC on chain, and that's powered by ZK Email as the source of proving that you've sent that Venmo payment. Among other things, we've also launched a couple, I guess, different marketplaces for trading tickets and trading domains on the secondary marketplace.
Hello, my name is Ash. I'm from Taseo. We build tooling and networks to build and deploy MPC-based applications. In particular, CoSnarks, which is what Cursive are using, and you heard a lot about this week. It was the first week that it's live, so we're very excited. And my role there, I care a lot about privacy. So I think about how using these tools in the real world actually affects the lives of the people using them.
Cool. My name is Andrew. I work at Cursive, and Cursive is exploring different ways for cryptography to enable new forms of human connection. So certain things that we're exploring are like multi-party FHE, looking at CoSnarks with Taseo, and also like new MPC primitives that we're like super excited about as well.
Very cool. I want to start us off with a high-level question, because you guys are building in a paradigm that is very new and different from most consumer apps that we're used to. And I'm wondering what are some application design patterns that are unlocked by these cryptographic primitives. And I want to address this sort of like in like ascending order. So in my mind, like ZK is the like most basic primitive, followed by MPC, CoSnarks, followed by MPFHE. So let's go in that order. Like, what are some design patterns that are unlocked for you? And give us examples from some of your favorite apps. Let's start with ZK Email.
Yeah, I guess we've seen two main ways people design applications that I think are different than everything we've seen before. One is around proof of received emails, so that's kind of the stuff that Richard and ZK P2P can contribute to. But it's very interesting now that it's very easy to make these proofs. People are kind of starting to compose them. So one example is you can prove you're part of a Slack workspace by using any Slack confirmation or invitation email, and then also prove you, for instance, took a flight on United and you ended up at Thailand. And now you can automatically build a system where everybody in your Slack workspace automatically gets reimbursed for their flight to Thailand. And it's kind of interesting because you're not just using one proof, you're combining all sorts of different proofs. And just because it's very easy to build each sort of proof, you can build these new applications that take multiple facets of your identity into account. And so that's one that I've been really excited by seeing. We've also seen on the side of using emails to send transactions, people kind of hot swapping almost emails and Ethereum accounts in their application. So for instance, multi-sig signers can just be an email instead of an Ethereum address. And it's kind of interesting seeing, okay, once that's really easy to do, then people start being able to expand their apps to all sorts of new kinds of users. So I think those are the two. And I think we've seen over the last few years the design evolve more into this being almost turnkey for developers instead of like ZK P2P, which had to slog through like months of the primitives of getting it up to speed. But we learned a ton from that. Yeah, I'm curious what your takes are, though.
Yeah, I think for us at ZK P2P, we're particularly focused and excited about the idea of bringing Web 2 data and using that like all across blockchains, especially. I think if you think about like Web 2, all the data currently exists in these like centralized data silos. Like you basically can't export them to use anywhere else. Think of like your Facebook or your Facebook friends. You can't just take that and use it on Twitter, for example, right? And some of these like ZK primitives allow you, and I guess also like MPC with like TLS Notary, allow you to kind of permissionlessly export these Web 2 like data from these like silos and use that anywhere you want. And we're particularly excited about like putting these on chain because of this like global like incredibly neutral settlement layer that you can do like really cool stuff and composable stuff with.
Who goes with co-snarks? You are using them. I can go general purpose MPC. Well,
You built them.
I think, I mean, with co-snarks and MPC, for co-snarks, I think one of the nicest examples is actually what you were doing, and this is essentially doing private proof delegation. So with zero-knowledge proofs, if you want to generate a proof where like the witness gets particularly big and you're doing it client-side and maybe your phone is not powerful enough or you don't have enough time to do it on your phone, you might want to outsource it. And so you see all these proof markets popping up that offer services that can generate your proofs for you. But if you have any notion of privacy at all, or if you care about the witness data and not leaking this in the clear to everybody, then you might want to do this in a privacy-preserving way. And I think this is where co-snarks enter the story. So doing, private proof, like proof delegation, but maintaining privacy in an MPC way, I think is the one real sort of awesome use case that co-snarks offer that wouldn't be possible otherwise. So like in yours now, you don't do proof generation on the phone, you outsource it to the network. And then I think for general purpose MPC, I think the thing, for me this is the most exciting part because there you start to now be able to collaborate on private data across multiple users. So I think ZK is great in the sense that it gives you like this sort of control over your data. But in a way, it restricts you because it's like, okay, I have control over my data, but now it's stuck and I can't share it with you. And sometimes I want this sort of flexibility. I don't want this all or nothing. And so if I have this flexibility to say, okay, I can share it with you and you and you, or I can share something about it with you and you and you, and we can compute over it together, then this is great. So for me, this is like the real kind of new thing that's opened up by using MPC in a ZK world, let's say.
Yeah, so I personally feel like ZK by itself is quite lame for the use cases that we're thinking about, which is social applications. Like, I feel like social is inherently like multiplayer. You want to get like a bunch of people involved, and the coolest applications there involve multiple people's private information. And for that, MPC is a perfect fit. So I would say for co-snarks, the thing that's more exciting to me personally is the idea that you can actually generate proofs about a group's data. So it's like the other side of the coin. And I think in general, like MPC, FHE, all of these things, cool applications or design patterns are like, one thing that we're trying to explore is asking questions to your social graph, asking private questions specifically. So one setup here is that like Richard could like have his like private data uploaded in some like encrypted form or whatnot, and I can just like ask certain queries, or I can ask questions like, hey, like, who here wants to join the hackathon with me? Like, does anyone in my social graph meet these criteria and wants to like be part of this group? And these queries would only be decrypted if they're actually satisfying that criteria. So I think like the MPC FHE angle feels a little more exciting for that.
Absolutely. I wanted to also, so this interesting theme sort of came up about making connections. So from Web 2 to Web 3, from one node to another in your social graph. And it's also kind of making connections between the primitives, like CoSnarks is a good example, FHE is a good example. So one question that's always at the top of my mind is security and how security assumptions compose both across primitives. So so you are introducing new cryptographic assumptions. How do these compose? And also across applications. And in that case, it's more about threat modeling. So for example, if you're relying on, say, the Venmo's email format, and they change it, let's say, or yeah, you're relying on like some DKIM server, some registry. Like, how do the threat models compose? So I'm so curious as designers how you reason about that, first of all, and also how you communicate it to your users, how you educate your users about it.
All right, I'll go first. So I think because ZK P2P is building like a financial application, if you will, we're dealing with like movement of, I guess, stable coins on chain. So there is real value tied to it. We do like treat security pretty seriously, both on the cryptographic side and on the application side. I think on the, I guess overall, we see like security as kind of like how comfortable are we like securing like this dollar amount over this amount of hours, for example. And I guess like different primitives that we use, I think fall under different parts of that spectrum. For example, like email may not be, I guess, the most, I guess, like gated and secured, for example, whereas like behind like a gated like private API with 2FA and everything, yeah, the data might be more secure. So I think we do account for all of that in like how much we allow like the max transaction limit to be in some of these protocols. And I think, yeah, I think we're constantly monitoring and seeing as these technologies mature, we feel more confident on it securing higher dollar amounts.
Yeah, I can also address trust assumptions on the ZK email side. I guess we think about this in two ways. One is around when things update, so you say your email template updates or the DKIM registry updates, it's one, very easy to change that. So we have a very simple builder where you put in the new format or the new parsing and it automatically handles everything for you. And so one thing is, okay, when a template changes, the developer's ability to react should be extremely fast. And then number two is we kind of want to make sure the system is robust to any weird kinds of like bugs or malicious DKIM key updates. And so one way we think about this, for instance, with email-based account recovery, where it really matters, like the entire security of your account hinges on, you know, it really shouldn't hinge on will this recovery module get hacked. And so one thing we think about is like very intentional time locks and kill switches. So for instance, like many of these accounts will have, once all the emails say, hey, I should recover this account to this new address, a 1-week time lock starts that's non-negotiable on chain. And so even if either the email server got hacked or the DKIM key got somehow maliciously rotated, or even like, you know, the user's guardians acted against their own will, then at least the account owner has a week to repair that. And so I think non-negotiable time locks has also been quite compelling. And the final thing is giving users the ability to exit. So for instance, for the DKIM keys, if a user doesn't trust, hey, these oracles they've set for the DKIM keys are going to always act correctly, we've made it so that users can say, look, I have to approve all DKIM key rotations that are applied to my account. And so now we kind of show, you know, in the, maybe in the UX, hey, confirm your guardian emails and the relevant keys. And the user just kind of does say some passkey authorization, and that'll automatically check, okay, I'm gonna do the DNS check, did the DKIM keys match? Okay, I'm gonna rotate them on chain for this user specifically. So allowing users to have control over their own keys within an intuitive manner, I think is also quite important. So yeah, these are the three ways. Easy updates, having it so that there's non-negotiable time locks, and giving users control over their own keys or parts or oracles so that they don't have to trust it.
Yeah, sure. For MPC and FHE, security is generally a lot more difficult. Like, there's been so much money being put into ZK audits and all these rollups and everything that like people know how to audit circuits very well. And for MPC, FHE, this is maybe becoming more of like a nascent thing. So we'll see how that progresses. I think there are certain things you can do to make MPC, FHE more secure. One way to look at it is there's this notion of direct security versus delegated security in MPC. So delegated security is when you take your private data and you split it up and you give it to all the MPC parties and they run this computation. Versus direct security is you are actually running this computation yourself. And you are one of the parties when you actually want to run compute over your own data. And that's like a simple way to say, oh, it's your own data, you should be a part of the computation. And I think that simplifies part of the equation or some of the threat assumptions. But I think for MPC, FHE as a whole, like, we're still trying to work this out.
Maybe I can add something on, like, I think you talked very nicely about the composability, but maybe I can try to say how this translates to users. And I think to end users in particular, like now we start to hear that like, oh, people do start to care about privacy and like, okay, yeah, we do have stuff to hide. So people do start to feel something about privacy, but I think they really don't understand like the nuance or even the language around it. So like explaining to end users, like consumers that we're talking about now, is just hard. And like, but even like for us now, we start to kind of onboard developers to use MPC tooling in the network. And it's like, even to developers, it's really hard to explain. And I think a lot of developers even have like a lot of confusion around the security assumptions. And like, it's actually a little bit worrying. And so like and as you said, like there's no auditing and like there's little sort of support for security in MPC and FHE and this slightly more advanced primitives. So at least we talk a lot. I mean, like all of us talk a lot to each other about like, okay, are we right in thinking this? And like with you, I was talking about private proof delegation and I was saying like, okay, just outsource everything. And you were like, okay, no, we're happy to outsource some stuff maybe, but like if there's like a whistleblower or something that's, you know, particularly sensitive or, you know, then no, like everything needs to be done client side. So I think having conversations amongst each other to like raise the general bar of education, like either amongst consumers and the developers and like the researchers and everyone, yeah, generally just raising the level of education I think is good. And that's what we do and try to, yeah, inform each other.
Yeah, I love that. I think a lot of, since we're building at a very early stage, a lot of it is about talking to each other and communicating well, communicating like in an intuitive way to users. So to that end, I want to sort of find out like some practical insights that you've gained from your experiences deploying these apps in the wild. So by practical, I mean like insights that you could not have gained from like just writing a white paper, just implementing it in a hackathon. For example, UX features, like Aayush said, making it clear to the users that they can control the set of DK keys they trust. So like UX prompts, how these cue behaviors in users, I'm interested in that. And I'm also interested in sort of how we compensate for the UX hit. So a lot of these apps, they involve heavy computations, right? For example, making a ZK proof. For example, having to be online for a long time for the MPC or FHE. Well, not for FHE, but yeah. So having to wait for a long time, be online for a long time, like these are UX hits that we have to take. How have you been dealing with those? So that's on the UX side. And then I'm also interested, like on the infra side, like actually what are the infra requirements? Like what difficulties have you run into? Yeah. Let's do the UX stuff first. Like what interesting user behaviors have you observed? What sort of UX prompts, UX patterns have you found useful? And how do you compensate for like the UX hit, the performance hit in these apps?
Okay. So for ZK P2P, we have two flows of interacting with these like cryptographic primitives that we use. The first one is obviously using ZK email. I think the main thing about using ZK email is trying to get that email in your inbox to start the proof generation process. And that's been a difficult thing to resolve. Basically, the manual way is you have to open like the raw email, copy it, and then paste it into the UI, and then click a button to run the proof generation process. So we basically built like a OAuth. We got a Gmail API OAuth flow that will basically OAuth into your inbox and read the email, but keeping it completely local and client side to kick off that proof generation process. So that has helped with UX a little bit, but it's obviously like a workaround kind of thing in trying to smooth out UX things. And also, after extracting that email, the next step is obviously generate that proof. Venmo email circuits are like massive. They probably will take like 8 minutes to do client side, but like 20 seconds to do on the server. So we pass it all through the server. And so far, I guess all of our users are fine with that. I think they're okay with that, leaking that level of privacy.
Do they know that they're sending the plain text email?
We disclose everything to the user that we are doing that. And then I guess the second flow I was going to talk about is we also use like TLS Notary, which I guess for that flow, you basically need to have the users like credentials in order to generate that like MPC proof. So in order to get that, you basically need to install or create a browser extension to scrape those that request and response in order to pass it to the MPC proof. And of course, all of this is done local and client side. But yeah, I think the reason for that is that's kind of non-negotiable. Like us storing cookies on a server, running cookies through a server and their credentials is like a complete no-go, whereas email is a little bit more okay in terms of privacy. But yeah, that's also a kind of UX hurdle we had to deal with, like trying to get users to install a browser extension and going through that flow.
Yeah, maybe one thing ZK Email learned a lot from ZK P2P is that, it's always important to have the clear user flow. So actually, after you guys added the Google OAuth flow and realized people are actually using this, we added it to all of the existing ZK Email apps too, where it's like you can, because we noticed, hey, as long as there is a way for users to do the easy path, and as long as that means we have to offer a way for the self-hosted or fully private path. And so it's kind of, as long as that path exists, it's kind of fine to have an option for easy users who don't care to just use the kind of simple sign in with Google, select the email, move on path, as long as it's possible for the people who really care about privacy to get that privacy they want. Either they manually upload the email, they select do it client side, they're willing to take the UX hit in exchange for privacy, or, and this is one of the advantages of having a totally open source organization is that all of our repos are open. Like you can go, if you don't trust ZK P2P's front end, or you don't trust ZK Email's front end, go to their GitHub repo, clone it locally, run it, and if you really, really care about privacy, there's always ways to get around the ease of use turnkeys that we've put into the UI. But for me, it's kind of like we've learned, okay, as long as there is the easiest possible path and a way for someone who cares about privacy to do the private path, we feel like that's been like a good enough mix of things, even if people in general don't necessarily always do the private path. So that's one UX pattern we've noticed has been really nice.
Bunch of thoughts here, I guess. First one is about privacy, and I feel like one of the main appeals of building consumer apps with programmable cryptography is the privacy you get, right? Is the choice and the consent that you have, and that is one of the major reasons why these technologies are so powerful. But I feel like if you go down the street and you just talk to people, I think what I've noticed is people just don't even understand privacy from your peers versus privacy from the server. This simple concept of hey, they look at your Venmo history, and if you look at it, you can have Venmo or whatever payments app you use, like you can have transactions only visible to your friends, only visible to yourself. Like people think when you set your transactions to be only visible to yourself, like that is privacy, right? That is like just privacy in general, that's what that means. But it's like a completely different concept when all this cryptography offers privacy from the server, which is really what we're aiming for, right? Like we don't trust server to get hacked or to be malicious or all this stuff. And I feel like this is really like a critical question we need to solve in like communication and design of how do you actually convey this to users. So here's one idea I can propose, which is like from Rachel at Cursive and also Tomo from the EF. Like they're both wonderful designers, and they have this idea, which they can talk more about, of like, hey, we should have some sort of like standard UI kit for like communicating to users. Like when you see this interface, it means it's actually private from the server. Like this looks totally different, it feels totally different, it is different, and that's actually connected to the technology, right? Because right now there really is no difference and people don't understand that. So I feel like having something like that where when the user actually uses the app, that would maybe change their perception of things a little bit.
You mean like a incognito mode or something?
Yeah, something like that. Like incognito mode, like it feels different because it's like dark.
Yeah.
Right? It's like, or I think of like the TLS like green lock icon. Like at the very least having some visual component where it's like, oh, it's not like a standard or something, but it's basically this norm you assume that if we have this green lock icon, then your connection is like more secure in some ways, and we're just gonna all like uphold each other to this promise. Because at the end of the day, like this is all up to like people building apps to just agree on and to like call out the people who don't follow this and to all work together to communicate.
I think that's a super nice point, and like if you look at cryptographic papers or whatever, when they like draw the protocols and the primitives, like they do have a sort of like it's hashed boxes, like there's lines in the box when things are secret shared, or it's a clear box when it's in plain text, or it's black when whatever. So it does exist, and I think this is nice. But one other point that I wanted to mention was a bit still on the design side, and also from Rachel, I guess, or from Cursive, is like that you really play with the ideas that, you know, like the concepts that these programmable crypto primitives give, and you sort of, you play with them in your own minds and sort of somehow translate this. I don't know about design or how you do it, but like you somehow translate this to the user. So like downstairs in the museum, there's these art pieces where there's the QR code that you can scan and input an emotion, and like it explains like, hey, we're going to send a hash of this and like prove that you know the pre-image. And like this is so cool. Like even just showing people the language and showing people like just mentioning it, just saying, okay, this is what's going on here, I think makes people aware, and like it's like, okay, cool, I'm doing some crypto.
Yeah, and so I was just getting lunch with Gordon, who's like the artist behind that piece. Like basically like we were talking about ZK cryptography for a while, for a few hours, and like he made this wonderful art piece explaining how you can keep your emotions private, blah, blah, blah. But I feel like what came out of that conversation is that the most important thing for all of us who are building apps in programmable cryptography is communication. Like we cannot just be technologists. Like if we want to actually build apps that people use, like we need to communicate and we need to talk to people and like explain, hey, this is what privacy means, this is why you should want it, this is what decentralization means, or whatever. Like communication is arguably like more than half the job. You can't just build the technology, build the primitives, and just like throw it out there and hope something good's gonna happen.
But it's not even just regular communication. It's like you make it look cool and fun and entertaining. And like if I'm using an app, okay, unless it's like a super serious thing that I want actual privacy, like real privacy for, fine. But if I'm just like using an app, I'm probably doing it for some sort of entertainment or like some fun, or to like engage with my friends or whatever. Like, and then having it like look cool and feel like a shiny, cool app, then it's great. And I think this is something that you do well. Like, it feels cool. I want to be part of it. So yeah, I think.
Yeah, like that's what's cool about Cursive is like they make it like joyful, social, and like it's sort of turning that privacy as like isolation and darkness kind of metaphor on its head. So that was really cool. I think, yeah, all these UX insights, there's no way to get them without deploying in the wild, without being in production. I guess I'm also interested in sort of on the back end, like on the infrastructure side. So I guess I have two sort of questions about infrastructure. First of all, is it expensive to run these apps? So it's a leading question because I know it is. I want to know how expensive and then like basically what improvements do you see in store? What improvements are you excited about? My second question is sort of a spicier one, and it's about decentralization. So, for example, WorldCoin, they're secret sharing their iris codes using Taseo to 3 servers. So, to me, 3 is a small number. How do we? Yeah, I'm wondering. Like another example is TLS Notary. So they rely on a set of trusted notaries to be the other party in the 2PC. And how big is this set? So yeah, it's kind of an infrastructure question, but it's also kind of a decentralization question, like underlying these primitives, like what implementations and what infrastructure are we actually using? And yeah, what are your thoughts on how this will develop?
Should I start? We laughed when you brought this up, and I wanted to explain why we laughed. And I don't know if I should say it like in front of a room because we haven't discussed this at all with the teams. But like, so like this week was the first time we deployed, let's say, co-snarks in like prod, like properly. So like this week it's like fresh out of the oven and it's like messy. It's been a bit messy.
It's all our fault. They didn't do
no,
anything
it's
wrong.
not like
totally
it's no
our
one.
fault.
So like, so the situation is this: like we have established a network. So Tatseo is running a bunch of nodes, Cursive are running a bunch of nodes, and PSE are running a bunch of nodes, and they all do computation. They do a multi-party computation between them and produce a co-snark. And so some of the things you might learn when you go into prod that you wouldn't learn in a hackathon, like as you said about like auditing and security, like being immature for MPC and FHE and the more advanced things, yeah, like infrastructure and support there is super not in place yet. So like yesterday we had a bit of an incident where 2 of the nodes of one of the parties died and they had 1 node left. And so this
is our party.
But like, okay, there was some sleep involved because they stayed up all night to finish the thing to actually get it done for Devcon. So it's a good reason. But yeah, like just the nodes died and they just needed to be rebooted, and that's it. But there was no like alarm or notifications or like anything set up. You know, this kind of like support that just keeps things online, or like small stupid things that are like the absolute like complete like essential things in any sort of advanced tech, not even advanced, but like used tech, like the most basic things are not there. And we focus on just getting things working, but like, yeah, this sort of support to keep it going, it's just not there. But, and in terms of cost, I also don't know if I should talk about this without knowing exactly, but like, I think for us setting this up, I think, is it for each party? I think it's about $7 per day for like seriously beefy machines. So, yeah, not too bad.
Yeah, I don't have much on numbers that I know of concretely, but I think in terms of like what you said, like this is not something that we would have learned this quickly if we didn't deploy it, right? Like this, we were using co-snarks for like the leaderboard, for like handing out merch downstairs. Like if you tap like 40 people, you generate a proof of it, and like you can get a shirt, the shirt that I'm wearing, which is super sick. But like we learned of this incident like literally 30 seconds in because people's leaderboards like weren't updating and they couldn't get their shirts. And like they were so mad. They were like, oh, where's my shirt? I want my shirt. Like my leaderboard isn't updating. So I feel like having that feedback loop instantaneously is like super useful, and we learned this lesson and like we fixed it overnight, and like now we learned something new.
Maybe I can add one good point and then I'll be quiet. But like the good point is that we had many more we generated many, many more co-snarks than we expected. So like the load was much, much higher than we expected. And the reason it went down was like, yeah, like it was not because of, let's say, so much load. But like we're handling much more throughput than we expected we could in like pretty good times. So that's the good outcome that we wouldn't have also expected without going into prod. And like a lot of it is because of the response of people at the conference actually. Like people are super curious and cool to try it out. So that's something we wouldn't learn.
Yeah, that's a good problem, like higher than expected throughput. And that's a good like alert system. Angry users demanding shirts. Those are like the joys of deploying in the wild and having real users. So I do think I'm supposed to open to questions from the audience, but I don't see any questions, do you? You don't really?
I think questions after that time.
Oh, okay, so we have 9 minutes left, and then we'll open to questions. Great, because I'm really not done here. Yeah, I think the second part of my question was, like, what do you see in the future? Like, future improvements that you're looking forward to? I, in particular, want to ask about mobile interfaces and whether, yeah, that's a priority for you guys. What challenges do you see, like, sort of what blockers do you have right now, and what challenges do you see in future, or what needs to happen to make like a joyful mobile experience for the users?
Maybe one thing we've thought about on the infrastructure side and on the mobile side is because proofs cost a couple cents on a server and will cost a couple more cents if you do co-snarks, there is quite a pressure to push things to the client side because then it's free. The user handles the computation for you. And so one interesting thing is that if ZK proofs get really big and if people are doing, you know, not just hundreds of proofs a day, but thousands or hundreds of thousands of proofs a day, then there's a really big pressure economically to create client-side proving. I think it's quite cool because client-side proving is kind of the holy grail of where ZK privacy comes in. You don't actually leak privacy to anybody else. And so I think it's actually potentially a good thing that we can incentivize this research. And so far there's only like, you know, maybe 2 or 3 organizations I can think of that are really invested in, okay, really we should get client-side proving today because you kind of like, you value in crypto often accrues to the points of centralization. And by saying we're going to do client-side proving, you're removing that point of centralization of we run the prover, we make the money. And so it's not currently economically advantageous for infrastructure providers to do client-side proving. But when applications are like, we don't want to pay, you know, hundreds of dollars a month or thousands of dollars a month to you, then all of a sudden applications are now incentivized to use somebody who is providing that client-side proving. And so, yeah, that's one thing that I'm excited about in the future, infrastructure-wise, and also for mobile proving. We've seen some teams like MoPro, like Ligatron, like teams in PSE, like Noir, really be like, how can we get this client-side proving done? And yeah, we're excited to see more of that. There's a lot of tech that has been underutilized, like WebGPU, SIMD acceleration, things you can get on mobile devices that you need for these email proofs because people, most of the time, are just going to scan a QR code, sign into their email on mobile, and make a proof. And you want to make that flow as fast as possible.
Yeah, I think for us, we echo a lot of the same things you said about client-side proving for our ZK stack. I guess for us, since we also use TLS Notary and the MPC side, we're especially also really interested in building like a mobile-based flow to enable enable some of our marketplaces. And the bottleneck there is, I guess, it's also memory, where like mobile has just much lower memory than on, I guess, browser. But yeah, also like bandwidth and internet connection matters a lot in MPC. And when you're on your phone, you're typically like out. So you may not have access to like high-speed internet, for example, to like finish generating these MPC proofs. And as a result, like the connection drops, which is a terrible user experience for some people. But I think there are quite a lot of like improvements like coming soon on the MPC front, on the TLS Notary front, which cuts the bandwidth requirement by like, I don't know, like a huge like factor. And yeah, we're pretty excited to adopt that and yeah, support mobile as a next step.
Yeah, I think like mobile is super interesting to us just because it has such a wide toolkit for social apps. Like things like Bluetooth, NFC, like Web Bluetooth, Web NFC, like they just suck. I don't know, they just don't work. Or like not supported by a lot of browsers. I think Apple has a lot of security restrictions on some things there. And it just sort of widens the toolkit of things that you can build in the social context. So I think like mobile to me is super important, and it also is just like a much more buttery experience than a web app. But then you have the question of like, how do you get people to download a mobile app? I don't know. Yeah.
There's these things called app clips now. You don't need to download a mobile app.
Tell me about app clips.
Yeah, it's so there's basically these app clips and instant apps on the Android store where like Google and Apple offer ways for you to like try out the app without actually downloading, going through the app store. So you basically scan a QR code, it loads some like temporary like a binary on your phone, and you get to interact with some limited features of the application without needing to go through the app store.
Maybe like one point that kind of touches on another question you wanted is like something that I'm excited about is something that I think both of you mentioned a little bit, is about the different models of MPC. So like the one where the user is actually part of the computation, or when it's a different, like you delegate fully everything to the network. And so like in some cases it can be that, you know, as long as one party is honest, that, you know, the whole thing can remain secure. And so if I'm involved in this protocol and I know for sure that I'm honest, then I can say that this is a good, like that this protocol is secure and there's no collusion happening. We're like quite, I think, not there yet at all for that, but like I would love to see this happening. This would be super cool.
Oh, absolutely. That's like one of the interesting thing about co-snarks as well, is because of the security guarantee from the snark side, you can relax requirements on the MPC side. And so, yeah, all these sort of interesting like paradigms emerge when you're like confronted with these use cases, and they can, like these use cases become interesting in applications. Like maybe in academia, they were not interesting theoretically, but yeah, like in practice, you realize, okay, like this is like an opportunity to like get some performance gains. Yeah, so that's a really cool point. I guess with my remaining 2.5 minutes, I want to find out what you're excited about. So, yeah, what applications have you seen that are like, wow, far out there? Or what applications can you imagine? What applications would be like holy grail for you? And this can involve like, this can be extensions of what you're working on now, or it can even involve like far out primitives that you're looking at, like witness encryption or something. Yeah, I'd like to hear what's in store for the next few months and years.
I personally really want to see more digital signatures and more ZK proofs of those signatures. I mean, emails is just one example, but if you can get, for instance, the signed website standards to be more adopted, you can get any website front end now approved on chain. And you can already do this for some things like Forbes in Italy, but it would be great if more websites did this. I'm also excited about PUFs, like physical unclonable functions, being the route for new open source TEEs. I think open source TEEs is kind of a holy grail and gives us the ability to do a lot of this private computation without having to rely on Intel getting hacked every 2 years. What else? I'm excited about witness encryption. I think more research around new kinds of privacy modes, and maybe I'll even let Andrew talk more about that. And yeah, I'm also excited about more far out things like making certain versions of I/O a little bit faster, or making having MPC FHE be faster. Things like we've seen like Apple's Wall-E, they just released like a ML and FHE kind of application, and I think seeing more of that, more enterprises get into these privacy protocols, make them faster. Yeah.
So for me, I guess, yeah, like making things faster, like harder, better, faster, stronger is always the goal. But I think I would love to see more like what you are doing actually, and I think there's not so much incentive to actually play with these tools. And I think the gain from playing with these tools and like onboarding users and educating them is huge, but somehow people don't do it enough. And so like there are apps like yours, like Tong, they're building these, you know, like salon basically where speakeasy, yeah, exactly, where you can meet your friends, like, and have this private environment where you can, yeah, like come in if you can prove some stuff, and like, yeah, this sort of transitive trust idea, like all this kind of cool stuff. Like this for me would be great. I'd love to see this actually happening more and more.
Yeah, I'm super excited about new applications of MPC. So specifically this concept called digital pheromones. And the idea here is that like real pheromones are these biochemical signals that you send around to find people you're compatible with. And what if we could build the same thing with MPC, but related to digital data, digital information? So you have these signals that you send around, and because everything is private, everything is safe, just like your normal pheromones are, you just get to see like where your compatibility is. You get to see who you match with, who you might be in a group with, who you might be able to do stuff with, and it just happens naturally. And so one way we can actually implement this is through a new scheme we came up with called Trinity. And Trinity is called Trinity because it's a combination of 3 schemes, specifically KZG witness encryption, garbled circuits, and Plonk. So the rough setup here is that you have your own private data and you just upload a KZG commitment of this into the cloud or wherever, and like people can just start asking you questions. People can start making private queries based on this data, right? And essentially like you only need to respond to these queries if you actually meet those criteria. Like these commitments are like pheromones from your data. They're like hiding commitments to your data. And you can just like naturally have other people around you ask questions and say, hey, like, am I compatible with this person? Like, am I able to do something with this person? And you can just discover that. And it's only possible because MPC enables this privacy and safety.
Yeah, I think I'm really excited about like more practical applications that like use these schemes that are like being like more and more robust and secure over, I guess, the next year. I think a lot of protocols, I think ZK email went through an audit, and a lot of these other like protocols such as TLSN will be, I guess, in the next year or two. And I think as these protocols become faster and easier to use, I think we'll see more and more practical applications like ours, and yeah, like stuff that you can do with Web2 data come online. And yeah, I think I'm just really excited to see like combination using schemes, these different schemes in combination with each other in production.
Yeah, very cool. So I think now we're supposed to open to audience questions. I still don't see them. Oh, there they are. So we'll start with the most upvoted, which is, yeah, what's the path forward for mobile? Do we need a new browser? Who will fund it? I guess like we already addressed sort of outsourcing heavy computations from mobile, whereas this question is, I'm interpreting it more of like sort of the current standards of mobile. Like you mentioned, there's applets now, but there's lots of sort of restrictions on mobile apps that make it hard to, say, directly interface into like TLS notary, let's say. So like, how do we deal with these standards that are incompatible with the primitives we need? Do we, yeah, how do we deal with them? Do we like start from scratch with a new browser? What do you guys think?
For mobile specifically, like, I feel like we just need more people building mobile apps and just experimenting. Like, that's basically it. Like, there's how many apps exist today on the App Store that are like mobile apps with programmable cryptography running client side? Like, I don't know. We don't have one. So I feel like we just need to learn the lessons there, pretty much.
Yeah, I agree with that. I think we need, yeah, more dev tooling, more developers building these kind of programmable crypto mobile apps. I think in particular, like, there's a lot of pain we experienced trying to do this in like yeah, the main requirement's being able to extract like the credentials through like a web view, like privately, and keep it local. And Apple just doesn't give you, or React Native or any of the mobile frameworks they don't give you that tooling right now. So you have to be pretty hacky when you're developing.
I think on the mobile browser side, one thing we really want is there's this kind of vectorization called SIMD, and you can only access 64-bit registers in mobile right now, but if we could access the full 256-bit registers, you could do ZK proofs a lot faster. Similarly, WebGPU exists on most laptops, but doesn't have very good support on mobile. So I think in the short term, if browsers can ship those, that would be super awesome. And then, but I do think the large browsers will have that eventually in mobile within the next like year or two, and that'll help accelerate a lot of these client-side proofs.
Cool. Okay, what are you going to have privacy by default, the hard path, not just privacy by complicated UI and default no privacy and limited security? I don't know how to parse this. Do you guys get the question? I guess it's kind of responding to something Aayush said about, yeah, like it's okay to present an easy path as long as we make available the fully private, like hard path of like completely self-hosted proving. Question mark?
Maybe one thing I can clarify on that is I think it is possible to have decent UI for things that are private. Like for instance, dragging and dropping the email on like a computer is not that bad. Like it's still an option in the UI, and it's definitely harder than signing in with Google, but it's not like you have to download something and git clone and run locally. Like you can still give option to do that in the UI, and we try to do that where we can. And so I do think, yeah, it's a fair point that forcing people to self-host is maybe not the best way to offer privacy, but I do think you can have buttons in the UI that, hey, this will take a little bit longer, this might require an extra action, but it'll be private.
How far are we from ZK-based transitive trust graphs of 10K plus users in dApps?
Good question. I'm looking at you. I would say, and I probably shouldn't say, but I would probably say it's closer than we think. I mean, it's a hard problem, and especially if you want to do this fully privately, like suppose you want to do like a full trust graph in MPC, you need to do like essentially a full search because almost everything is connected. So it's super inefficient, and it's, yeah, not so good now. But I would imagine that, like, I mean, the speed at which things are improving now, I would say not too far away. But
Yeah, I think technically it's possible. For me, it's like how to design this like protocol-wise. It's like, how do you do this the right way where this is like fair for people? There's a lot of like tricky, I don't know, moral product questions that are to be answered here.
Mm-hmm. I was also thinking just now that FHE is one example where like you cannot offload and don't want to offload to client side. You fully want the server to absorb the cost. So yeah, like I guess and the trade-offs, you know. Oh, sorry for gesturing. This is just my opinion. Like the trade-off is just individual users doing less work, and that could maybe allow you to scale to 10K plus users. But yeah, like you said, it's a big design space. All right. How do you solve the issue of querying large databases efficiently in MPC? All queries are linear in the database size, no?
Maybe one quick thing is like Apple Wally, like their new FHE system solves this by one, like bucketing. So you say, look, we're going to make square root of n buckets, and we're going to send it to the right bucket. But then you leak a little bit of information, which is which bucket did the query go to. So they send square root of n queries. And then it's like, well, you know, which query is the right query? You don't know, and the user throws away all but one of the queries. So I thought that was a kind of clever way to, you know, leak a little bit of privacy, but then undo that leakage and have it be a bit more efficient.
Oh, okay. So it's like linear over square root n buckets?
And you can keep kind of recursively doing the square root of n.
I see.
Yeah.
How about, I know WorldCoin does have this, they do a database search per new iris code.
So yeah, we do actually search over the full database for this, and like it is quite optimized and it's quite efficient, but like it's heavily specialized, optimized protocol so far. But I mean, there is work definitely on like lookup tables, and like there are ways. I mean, people are looking into this and coming up with like clever tricks like this. But yeah, so far it's people are looking into it, but it is still an issue.
We need more PIR research. PIR is really cool. Private information retrieval.
Isn't PIR also like linear work on the server side though?
Yeah. Right now, I think you just like encrypt the whole database. Yeah.
But not for the user. Yeah. Cool. So I think we are over time now. And I really love this panel. Thank you so much to the panelists. Thank you.
Thank you also
All right,
for
thank you
making it
guys.
nice.
I actually had to sit